Lesson 10 is about rate of change, and in 10.1 we're going to talk about a linear rate of change. So linear functions, those are functions that have a consistent rate of change, meaning it's the same over time. So a few examples of like real life linear functions would be like if you're earning $10 every hour, that's not changing, you're earning $10, that set amount per hour. Another one could be saving $5 per week or running a consistent 6 miles per hour. So linear means that it has a consistent rate of change, the same rate of change over time. So even if like you work and you make $10 per hour, like your total amount of money, I guess, that you have would be increasing. The amount that it's changing by is not. It's changing by $10 each hour. And then the formula for a linear rate of change is m equals, that triangle is called delta, so delta y over delta x. It's the same like slope that we learned earlier in the year, where it's like rise over run, or like for example, sometimes it's written as y1 minus y2 over x1 minus x2. There's just a bunch of different ways of writing that like same thing of like a linear rate of change or a linear slope. So that triangle, like I was saying, is a symbol called delta, and it just is a kind of shorthand for change. So this would be like the change in y over the change in x. And when you're looking at a graph, that would be like rise over run, like your vertical change, so how far you're going up or down, over your horizontal change, so how far you're going side to side. So, sorry, it's kind of crooked. So how far you're going side to side. So change in y, or like triangle or delta y, is the vertical change up and down. Change in x or delta x is the side to side change, like left or right. Okay, so example 1, find the rate of change from the graph. So when we're looking at a graph, we can really use like rise over run. I'm going to add those words in here as well. So vertical change, sometimes like the word that we use to describe it is rise. And then horizontal change, sometimes the word we use to describe it is run, like sideways. Okay, so example 1, find the rate of change from the graph. In order to do that, we just need to identify any 2 points like that are kind of like exact points on the graph and count the rise over run between those 2 points. So I'm just going to write the formula really quick. So it's m equals the change in y over the change in x. Remember, m is like just the letter we use to represent like slope or rate of change. So the like change in y, that's going to be the rise. So between these 2 points on here, 0, 1, and 1, 4, my rise is I'm going up 1, 2, 3 units. So my rise would be 3. And then for my run, it's how far am I going like side to side to get to my point. So after I go up 3 units right here, I have to go to the right 1 unit to get to my next point right there. So my run would be 1. So the run or the change in x is 1. I'm going to add run to this as well, just as like a quick little reminder as we're getting re-familiar with this formula. So rise was 3, we went up 3 units, and then run was 1, we went to the right 1 unit. If you go down, your rise would be negative. If you went left, your run would be negative. And then if you can simplify it, you want to. So like 3 over 1 just simplifies to 3. So our rate of change would be 3. Okay, so example 2, find the rate of change from the table. I'm going to rewrite the same formula. So it'll be m equals change in y over change in x. And if you look at the table, the left side has an x there, but the right side has f of x. So it's important to remember that f of x and y are interchangeable. So like you could literally swap one out for the other and it would make no difference. So thinking of f of x in terms of y for this problem might be helpful. So for this one, we can kind of count the change or look at the change from the table from one spot to the next. And we just need to pick any like 2 kind of consecutive points. So like, for example, this would be 1 point and this would be the other point. But let's say like you don't want to deal with negatives. You don't have to. You can pick any 2 points that are next to each other. So like, let's say right here to right here. So the change in y, or change in f of x, is how am I getting from 1 to 4? Well, from 1 to 4, I'm going up 3. So my change in y would be a positive 3. And then for my change in x, it's how am I getting from one x to the other, like from that same set of points. And I'm going from 0 to 1, so I'm going up 1. So my change in x would be 1. So we actually ended up with the same thing, like 3 over 1 for our rate of change. So we want to simplify it if we can, and of course 3 over 1 simplifies to just 3. So m, or our rate of change, equals 3. And it's important to know, like for a linear function, it doesn't matter which points you pick on your table. You just want to pick kind of 2 points that are, honestly, you don't even technically have to pick 2 points that are next to each other. Now that I really think about it, I'll show you why really quick. But you just have to make sure that you are like kind of picking your points so you don't accidentally mix them up, I guess. So you don't need to write this, but like the reason that you don't have to pick like 2 consecutive points even, or like you have a lot of freedom with what points you pick on the table, is because like, let's say I go between, I'm going to go between this point and this point. So they're not even next to each other. My change in y, and again, you don't need to write this. My change in y, I'm going from 1 to 7, so that would be 6. I'm going up 6. And then my change in x, I'm going from 0 to 2. So 6 over 2 would simplify to 3, which is the same answer we got when we picked 2 consecutive points. So you have a lot of freedom when you have a like linear rate of change on your table to pick really any 2 points. You just kind of want to point them out so you don't accidentally like mix up any of them. Okay, so 10.2, linear functions and average rate of change. So now we're moving on to non-linear functions. So examples of non-linear functions would be like something that's an exponential or a quadratic. They do not have a consistent rate of change. So like, for example, if you had like a savings account that you put money in and then it accumulated interest, the more money like that is building in the account, the more interest is going to accumulate. So it's actually increasing more and more and more. So it's not a consistent rate of change. So that would be something that's non-linear. However, we can find the average rate of change of a function over a specific interval. So example 1, find the average rate of change over the interval x is greater than or equal to 0 and less than or equal to 3. So what that means is that we're looking between x equals 0, the first number, and x equals 3, the second number. So something that I think is really helpful is to like kind of give yourself a visual of what your interval looks like on the graph. So I would look at the x-axis, which is this one, and I'm going to put a dotted line at x equals 0, which is right here, 0 on the x-axis, and at x equals 3, which is right there. So, and you don't have to do this as you get more comfortable with it, but I think it's helpful to see it the first couple times. So x equals 0, that's here. Sorry, it's like a little bit off. But x equals 0 is right here, and x equals 3 is right here. So we're looking for the average rate of change in between those 2 lines, so over this section of the graph right here. So we need to find, in order to find the average like rate of change, we just have to find like kind of the 2 endpoints of that interval, which those are the points that are labeled on the graph. So we're looking at the point 0, oops, that's still a dotted line. We're looking at the point 0, -2, and 3, 5, and we're finding the rate of change between just those 2 points because those are like the starting point of the interval and the ending point of the interval. So we treat it the same way as like the previous problem where we can find rise over run. We just have to identify those points of like starting and ending the interval first. So write down the formula. M equals change in y over change in x. Or it's the same thing as rise over run. So for change in y, that's my rise. And then change in x, that's my run. So from our graph, I'm going to start at 0, -2, and then I'm going to go up to 3, 5. So for my rise, I'm going up 1, 2, 3, 4, 5, 6, 7 units to go up from 0, -2 up to 3, 5. So my rise will be 7. And then for my run, it's how far am I going side to side. So after I go up 7 units, I'm like right here. And then I just need to go to the right 1, 2, 3 units to get to my next point. So my run is going to be 3. And since I went to the right, it's going to be a +3. So my run is +3. My rise was +7. So the average rate of change over that interval is going to be 7/3. So m equals 7/3. And again, that's not the rate of change for like the entire graph or function or anything like that, but it is the average between that interval. So to find the average between any interval, we need to kind of find the endpoints from that interval and find rise over run between them. So moving down to 10.3, this is comparing rates of change for multiple functions. So example 1, compare the rates of change over the following intervals. For A, we're going to do between 0 and 1, and for B, we'll do between 1 and 2. So 2 very separate problems, and we're going to have to find the average rate of change for each function for each part. So we'll end up having to find 4 different rates of change. So we're just going to focus in on the interval of x is greater than or equal to 0 and less than or equal to 1. So that means when x is between 0 and 1. So we look at the x-axis, which is the horizontal one, and x equals 0 is right here, and x equals 1 is right there. So I'm going to draw my interval in. So this is x equals 0, and then this is x equals 1. And the interval is between those two dotted lines now. Okay, so to find the rate of change, we have to kind of figure out where is the function beginning in that interval and ending in that interval. So we're going to find f first, and I'm going to do my best to try to keep it like kind of color-coded. So f I'll keep in blue, and then g I'll keep in red. Notice if you didn't see it, like the blue one has a little f next to it. That means it's the name of the function. The red line has a little g next to it. That's the name of that function. So we still need to use that formula. So it'd be m equals the change in y over the change in x, which just means rise over run from a graph. So we need to find the point where function f starts in the interval. I'm going to zoom way in actually. And it starts in that pink interval right here, and where it crosses out of it, which is right here. So we would need to find the rise over run between those 2 points. So for my rise, I'm going up 1, 2 units, this section right here. And then, so my rise would be 2. And then for my run, I'm going to the right 1, 2 just 1 unit. I'm going to say that again because that was butchered. For my change in x, that's my run. It's how far side to side I have to go. I have to go to the right 1 after I've gone up 2. So my run is 1. So if we have a rise over run of 2 over 1, we want to simplify that down to just a 2. So my rate of change for function f over that interval would be 2. Okay, I'm going to draw that in one more time just to get a little bit closer look at it. But rise, I'm going up 1, 2 units, and then my run, I'm going to the right 1 unit, so it'd be 2 over 1, which simplifies just to 2. Okay, so now for g, I need to pretty much do the same thing, but I have to find my new starting and ending points. So for g, that's the red line. It crosses into the interval right here, and it crosses out right there. So now I'm finding the rise over run between those 2 points. So we'll set up our formula. M equals triangle y over triangle x, which means the vertical change over the horizontal change, or rise over run. So for my rise, I'm going up 1, 2, 3 units. So my change in y, or my triangle y, would be 3. And then for my run, or my triangle x, change in x, it's how far side to side do I have to go. And after I've gone up 3 units, I need to go over 1 unit. So it'd be 3 over 1. And then 3 over 1 just simplifies to just regular old 3. So my rate of change for g over that interval would be 3. Okay, and then sometimes you'll be asked to state which one has the greater rate of change or a higher rate of change. So in this case, or at least over this interval, g has the higher rate of change. Okay, so moving on to part B, this is over a different interval. It's between 1 and 2. So that means that this interval that we have drawn on the graph no longer applies because this was between 0 and 1. So I'm going to erase all that. I'm going to focus back in on the x-axis, and I want to find where x equals 1 is, which is right here, and x equals 2, which is right there, and I'm going to create a new interval. So this is, wow, that's really crooked. This is x equals 1, and this is x equals 2. So now I'm finding the average rate of change between those two lines over this new pink interval. Okay, so we're going to approach it the same exact way. I'm actually just going to go ahead and copy this part down because it's going to look exactly the same. So for function f, if I want to find rate of change, I'm finding the rise over run. So I'm going to zoom in and find my starting and ending points. So for f, it crosses into the interval right here, and it crosses out right here. So I'll find the rise over run between those two. So for my rise, I'm going up 1, 2, 3, 4. And then for my run, I'm going over 1. So it would be 4 over 1 for rise over run. And then 4 over 1 simplifies to just regular 4, so my rate of change, average rate of change over that interval for function f would be 4. So one thing that we know about, before we move on to g, but one thing we know about linear functions is that they have a consistent rate of change, which means that they have a consistent slope, or on a graph, they're a straight line. So technically, g is a linear function because it's a straight line on a graph. So that means that we don't actually even need to find rise over run, because if it's linear, it's going to have a consistent rate of change regardless of the interval. So that means that it's going to have the same rate of change as part A. So if I want to just take my answer from part A, I can. And that's always the case for any time you have a straight line on the graph, because it's not bending and changing. Whereas for function f, you can see it's getting steeper and steeper. Function g, the red line, is staying exactly the same. So that rate of change would just be 3 for g, and for linear, they will be the same rate of change regardless of where you're looking on the graph or regardless of where the interval is. So now for part B, we can compare and figure out which one has the higher rate of change, and this time function f has the higher rate of change. It's 4 versus 3. So for part B, function f has the higher rate of change. And if we kind of look at how the graph is trending, as we get later and later in the graph, or further to the right, f is becoming more and more steep. So really from that interval of 1 to 2 forward, it's going to be a higher rate of change than g, because f is going to continue to increase. It'll be 5, 6, 7, 8, and so on, versus g is going to stay exactly the same regardless of where we're looking at on the graph.